Hello, hello class. Today what we'd like to talk about is composition of functions. Now, in fact, simple composition was already talked about in pre-calculus classes. Today what we'd like to talk about is uh, maybe more like a decomposition of functions. That's what we'd like to look at. And then part two of this video will deal with domain and range, which should be quite interesting. All right, so then let us try to look into this topic first. So given that f of x is equal to 3x squared plus 1, and g of x is equal to square root of x minus 2. Now, where function h of x is composition of f of g of x. Now, my first question will be finding what is h of x. So why don't I ask you to work on this question just a little bit, right? Okay, great. Now, so in this case, let us try to look into this one together. Since h of x is composition of g of x, this expression has to go into the function f. That means we are looking at h of x must be equal to f of g of x, which is square root of x minus 2. All right, now, in this given context, then this expression has to go in place of x to figure out the rest. So this becomes 3 times square root of x minus 2 whole thing squared plus 1. Now, and in this case, when we have square root and then square, those two will be reduced as having 3x minus 2, where x minus 2 is in parentheses, and plus 1. So when you simplify this one even further, what would have happened is we get 3x from here minus 6 plus 1 becomes minus 5. So hence that becomes our final answer. Alright, then at this point, when you look into this question, so yes, we've been talking about in many classes how to find h of x given f and g. But our natural question would have been something like this. Given h of x, can we find maybe f of x? Well, how about g of x? You see, so out of three expressions of the functions given, out of 3 functions, if we are given 2 functions, can we basically figure out the other one? That's basically what we like to look at. Now, then as an example, what if I were to give you something like this? So, case number 1 would be finding out f of x. So let me give you one simple example. If we have h of x in this given setting, let us say h of x is equal to 2x. All right. Now, and also g of x in this case. Simply put, how about let me try to do something similar as to the last one. Square root of x plus 3. And can you somehow find f of x? All right, I'll give you a little bit of time for you to work on, and then we'll continue to talk about this one further. All right, then, great. Assuming that you already have the answer, in this case, first step which we can do would have been, since we know the 2x for h of x, and then g of x would have been this, let us simply substitute them in and then see what happens. Then our answer will be 2x, which will be equal to, in place of h of x, and then we have f of square root of x plus 3. Now, I'm sure we can come up to this point. Now, some of you guys at this point might be able to reason out insightfully and then figure out ultimately h of x, what h of x being equal to. Somehow you might have to get there. But the thing is, that intuition is great, but is there a way for us to somehow make them more systematically? That actually tells us that we need to focus on this portion. What can we do to this expression so that we can get x by itself? Wait a minute, what can we do under composition, because that's what we're looking at here. What can we do under composition so that we can get x? In fact, that is a great idea because we have, let us say if I have two functions, I like to call it maybe k of x. But what can I do to this function? Let's call it maybe j of x. How about j of k of x? Somehow I do some sort of composition and to become x by itself. In fact, knowing that x is the identity function under composition, then this in fact j and k simply becomes inverse of each other under composition. Now, then, what we are looking for is, that's right. Essentially, we want to get rid of this one. That means we are looking for inverse of this expression. And somehow we can try to find this. Then let us try to find the inverse of square root of x plus 3. Given that g of x is equal to square root of x plus 3. How can you find inverse of a function under composition? Many times I expressed as g to the negative 1. That negative 1, in this case, we're talking about opposite of the composition, inverse under composition here. So then, many times what people tend to do is y is equal to square root of x plus 3. We can just use y in place of g of x and switch x and y. Then we end up getting x equals square root of y plus 3. Now, in fact, this is the inverse of that expression. But given that, what we need to do is, if you have to solve for y, then it will make things so much easier. So here we have y plus 3 would have been equal to x squared. And when you subtract 3 from both sides, y will be equal to x squared minus 3. In other words, the inverse function of that is x squared minus 3. So in fact, in order for you to get rid of this radical and also 3, then what we need, the expression which we need is x squared minus 3. Now, since we are using x already, so just for the clarity's sake, what if you had to use on the side, let me just write it down here, that x equals, I'm just going to use another variable just so that we can clarify that, a squared minus 3, because that was the expression. What if I were to use a instead of x? So if you had to substitute a squared minus 3 in both places, then we would have gotten f of square root of a squared minus 3 in place of x plus 3 has to be equal to 2 times a squared minus 3. Then, as you can see, subtraction of 3 with the addition of 3 will cancel out, and square, and then square root also will cancel out. Now, so then in this case, what's going to be happening is on the left side, we will end up getting 2a squared minus 6 will be what we end up getting, and then on the right side, we end up getting f of a. Now, technically, square root of a squared would have been absolute value of a. but for the simplistic sake, we just want to put it as a, and then we're going to assume that a is the positive values that's allowed within the given domain. Then we end up getting expression that looks like this. Now, by the change of the variables, instead of writing a, if f of this is equal to 2 times this square minus 6, then f of x should have been equal to 2 times x squared minus 6. Therefore, that becomes our answer. Now, how can you be sure that that would have been the answer? One way which you can do it is simply plug using this one. What if you took the decomposition? Would you end up getting our original answer, which is 2x? Just for the review's sake and checking through, why don't we actually do the composition and see if that actually makes sense or not. All right, so here it goes. To check h of x was 2x, and f of x, f of g of x, since g of x was equal to square root of, so I'm just going to write it as f of square root of x plus 3. Now, of course, this portion will be substituted in under this function right here. So if you have to write it once again using this function, then we'll end up getting 2 times. In place of x, we're going to put this expression, square root of x plus 3. And then we're going to square that, minus 6. Notice the structure of this expression is identical to f of x. Then let us see what we end up getting. Here we have square root, and then square will be reduced as x plus 3, simply. And subtracting 6. And once you look at it, this becomes 2x plus 6 minus 6 by distributing of 2 onto 2 terms here. And as we see positive 6 and addition of 6 and subtraction of 6 will cancel out, we end up getting 2x is equal to 2x indeed. So we know that that would have been okay. Now, then why don't I get you just one question for you to do, and we'll look into them together. So this time, given, once again, same as before, that h of x is equal to f of x, f of g of x. This time, what if I were to say h of x is equal to, how about sine of x, and then g of x, let's call it as, how about e to dx. Now, can you find f of x? Right. Once again, I'm going to give you a little bit of time for you to look at, and then we'll see what happens. Oh, great. I'm sure you you had a great exercise already solving this question. So therefore, let's try to work on this one together then. Now, just like before, let us, since we know these two expressions, we can substitute them in, and then we'll end up getting sine of x in place of h of x is equal to f of g of x was e to dx. Now, then here we have, the thing is, what can we do so that we can get rid of e to dx? Then we need to figure out, just like before, inverse of e to dx. Inverse of e to dx, we know that is ln of x we're going to put in place of x's. Then what do we end up getting? Sine of ln of x will be equal to f of e to the ln of x. After reducing e and ln, we end up getting f of x. Here we have sine of ln of x. There it goes. That becomes our final answer. So in fact, if you were to generalize this, what would happen is this. Given that when we have h of x for f of g of x, what can we do so that we could have f of x alone? In fact, that becomes the question, isn't it? That means generally what we are doing here is that we need to get rid of g of x. How can we get rid of g of x and leave it as x by itself? Once again, using decomposition. So in fact, in place of x, what we're trying to do here is f of g of, let me just leave some space, and then h of, you see in place of x's, what we are actually doing is this. Notice that if we have g of inverse of g of x, we would have gotten identity function, which is x. That's the whole idea which we are looking at. So in fact, when you substitute inverse of g, and then same here, inverse of g, then original function g and inverse of g will reduce into f of x, and on our left side we'll end up getting h of g inverse of x. That's basically what we end up getting, and this becomes our first relationship. All right, then that was simply case number one, because case number two now would have been given h of x is equal to f of g of x. Of course, our next part of the question is, what if we do not know g of x? We know f of x, but what if we do not know g of x? So first, why don't I get to some relatively simple question, and then we'll try to look into that together. So, given first relationship will be this one, I guess, and also h of x, let us say, is equal to 2x. So same as before. How about this time f of x? What if we were to say f of x was x squared, for example? Now, then how are we going to get rid of, or how are we going to get g of x by itself? Now, then one way which we can do this, let's try to plug them in and then see what happens. So first we have 2x in place of h of x, which is equal to g of x will be going into the function f, but function f here is x squared, so we'll end up getting g of x squared. That's basically what we'll end up getting. Now, how are we going to have g of x by itself? Basically, we need to get rid of the square. One way in which we can do it is simply taking the square root on both sides. So we'll end up getting g of x would have been equal to square root of 2x. In fact, due to multiple values in this function, we will have positive or negative. We have no idea which one it would have been, I guess. So our answer would have been positive or negative square root of 2x. All right. So given this, let us look at one more question, and then see what happens here. So, given same idea, and let us say h of x is equal to e to the x. How about that? And then f of x would have been equal to sine of x. And I'm looking for find g of x. Now, once again, as we compose with the known expressions, we're going to have e to the x has to be equal to sine of, instead of having x, we're going to have sine of g of x. Now, at this point, what we'd like to do here is we would like to keep g of x, but we want to get rid of this sign. How are we going to get how are we going to get rid of this sign? In fact, once again, since we are looking at competition, one way in which we can do it is this. We can get rid of sign using the arc sign. So what if we have arc sign? Now I'm going to leave some space here, and same here. The reason why I'm using arc sign is because there will be the inverse of sine under competition. Given that both sides has arc sign, as long as the value that goes in here will be equal to each other, meaning right over here, then you will realize that the equation is still satisfied. So in fact, on the left side we will have e to the x. On the right side we will have sine of g of x. Now, then you will realize that here, once again, arc, sine, and sine, they will be reduced into g of x. And on the left side, we will have arc, sine of e to the x. That's basically what we'll end up getting. All right, very nice. Then in this case, what we like to do is this. Okay, then essentially, what's actually happening on this second case? Let's look at the general case together. Once again, given this, what we want to do here is that we want to get rid of f. Once again, by using the idea in this case, inverse and then original function, when they're composed together, we will end up simply getting x, meaning, notice that's the value inside. So in order for us to keep this by itself, then what we need is we need to compose them with inverse of f. Now, since this portion is exactly the same as right here, when we put this part in competition with inverse of f, then we have to do the same thing on the other side. Then here you will realize that these two will be reduced. Having g of x by itself on the right side, on the left side we will have inverse of f of h of x. In fact, that becomes our general relationship for the second case. All right, so I'm going to prepare more practice questions at the end of this chapter, and I hope you guys can enjoy that. All right, have a nice day. Bye-bye.